triangles are similar. Do you remember when we did congruence? We did it the hard way. We did like all three sides and all three angles are congruent. Then we said triangles are congruent. But then we learned the shortcuts. What were the shortcuts? Side, angle, side. Angle, side, angle. Hypotenuse, leg. Side, side, side. Angle, angle, side. Okay? Those are the 5 congruent shortcuts. So now we didn't no longer have to prove all 3 angles and all 3 sides are congruent. Same thing with similarity. We don't have to prove all 3 angles are congruent and all 3 sides are proportional if we use one of these shortcuts. And the shortcuts are kind of similar, but not exactly the same as congruence. We've got angle, angle, similarity, which is if 2 angles of a triangle are congruent to 2 angles of another triangle, you're allowed to say the triangles are similar. Okay, that's kind of opposite of congruence, right? Because we aren't allowed to use angle, angle for congruence, but we can for similarity. Okay, we also have side, side, side similarity, and that is if the 3 sides of one triangle are proportional to the 3 sides of another triangle, then they're similar. And side, angle, side similarity, and that would be like if I had a thing here and here, and I'm making up, this is not a real symbol, I'm just making this up. So if these 2 sides are similar, and these 2 sides are similar, and the angle in between them is equal, then we can say these 2 shapes are similar by side, angle, side similarity. Okay, just like congruence, it's got to be in a row, you can't have a dead spot. Okay, now let's use those 3 shortcuts to prove or not, or disprove that these shapes are similar. Okay, so let's say we're trying to prove that ABC is similar to ZXY. How would I do that? Anybody have an idea what kind of shortcut? I think I'm going to use sides. Do I know any of these sides? So chances are I'm not going to use sides. So what's the only one left? Angle, angle. All right. Well, do I have any angles that are congruent? Yeah, the right angles, right? This one and this one. How about these 2 aren't equal, but what can we find the measures of those third ones and see? What's the measure of angle C? 90 minus 43? 47. And 90 minus 47? 43. So do I have some more congruent angles? Yeah, this one and this one, right? Or the other 2? Right, 43 and 43. So I can say these 2 angles or triangles are similar by angle, angle similarity. And what would my triangle congruence or similarity statement be? I'm sorry, Becky?
Triangle ABC is similar to triangle XY.
What goes with A? Which angle is equal to A? Z. B goes with? Right. Good. Okay? All right? Take a second and see if you can figure out, and copy this down because it's good note-taking to have some examples in your notes. Because the reason I picked these examples is because you're going to see them again on your homework. So copy this picture down and see if you can prove they're similar. Okay? Go.
Okay, well, 12.
Speak loudly and it's that little, I try to turn myself, but.
Okay, well, 12 is less than 15 and 16 is less than 20, so these 2 go together. 12, and 16. So 12 is 3/4 of 16. So it's a 3/4 ratio, and 15 is 3/4 of 20. So I know that the 12 and 16 those are similar, and 15 and 20 is similar. And then I know that these two angles.
Mark them on there.
Um,
with this.
I know that these two angles are.
Just go ahead.
Okay, well, these two angles are congruent because they're vertical angles. So I got the side angle side, and then the similar
Let's do this last one before we get into the last target we had, which was use similar triangles to figure out the measurements of sides and angles. This one, the key here is to see the triangles. So the first triangle is this big one here, right? ADC. And then the other triangle is the littler one in here, right? So even though one's laying on top of the other, okay? So that's kind of the trick for those. One's laying on top of the other, but you still can prove they're similar. So take a second and see if you can figure out. Okay, so we've got an angle that's congruent and a side that's congruent. So we either need another side or another angle. Which one did you find? Yeah, why? Yeah, what property is that? Reflexive, right. It says that A belongs to the little triangle and to the big triangle. So A is congruent to A, so that gives me another angle. So which shortcut am I using? Angle, angle. Okay? And angle, angle, these two triangles are similar by angle, angle, and what would the similarity statement be? Sahara? I haven't heard your voice today. DBA is similar to triangle DCA. Okay. We all agree with that? Yes. Sure. Sure. As long as the angles match up, you can write them in any order you want. Okay? All right. Then the okay. Okay. The last target we had today was once we prove triangles are congruent, or similar, we can use that similarity to solve for missing sides and missing angles. So let's look at an example of that. First thing you have to do is to determine, are these triangles similar? Are they similar? Yeah, isn't it just like the one we just did? These two angles are equal, and what other one? Yeah, the reflexive one, the 77, right? That's going to happen a lot. You've seen that pattern. Okay, so we know they're similar. That means all the angles are congruent, all the sides are proportional. So let's start by finding the measures of all the angles that are missing. A, B, and C. Okay, what's the measure of angle A? Julia?
3/4.
Right, they're equal, they're even marked, right? Okay, how about the measure of angle B or C? I don't care which one you do first. Josh, why don't you try it? How'd you get that? Well, just tell me you did it, no. Okay, what, like, this triangle, right? So what do you know about the angles inside the triangle? Yeah. So you add 34 and 77. That gives you what, 111? And then subtract it from 180? I think it's 69. Yeah. All right, so C is 69. What's B then? 69 as well. They're equal, right? They're the corresponding angles. Okay? And then for X and Y, the missing sides, we know that whenever you're trying to find missing sides, you have to have one set of sides that are given so you can find the missing, so you know that what the ratio is. Okay? Which sides are we given? Yeah, 18 and 6. Exactly. So I'm going to make that into a ratio. 18 over 6, or reduced would be 3 over 1. Because remember from before midterms, ratios are always reduced. All right, so I know the ratio of the big triangle to the little triangle is 3 to 1. So if I'm trying to find X, what's going to go on this side? Which is 24 going to be on the top or the bottom? Top over X, right? Cross multiply and solve, you get 3x equals 24, so x is 8. Okay? And this time the bigger triangle side is missing, but I'm going to use the same ratio, right? Don't all the sides have to be the same? So I'm going to use 3 to 1 again. Only this time, where's the y and the 5 going to go? Y over 5 or 5 over y? Y over 5, right. Okay, 1 times y is y, 3 times 5 is 15. Okay? All right. So tonight, you have a book assignment if you'd rather do that, but I also put out a